we have electromechanical relay system. So when you want to automate the process, what you have in mind is you want to make sure that the system can work effectively with little uh, human intervention. Okay. Now, these are basically the kind of systems we can use to automate the process. We have the electromechanical relay system, which are the ones that are used in the railways. We have the embedded system, and then you have the programmable logic. So, the PLC you are talking about, programmable automation controller, is just more like an advanced PLC. Maybe later on in some other cases or other classes, we will be talking about what PLC is. Now, what differentiates these three? Which of them is suitable for industrial setting and why? Which of them is not suitable for industrial setting and why? The question is this. We have established that this can be used in automating industrial systems. Sorry, automating a process. Now, my question is, which of these are suitable for automating industrial processes, and which one is not suitable? Now, the suitability of any of these systems will be with reference to the context. Will be with reference to the context. Context is the sense that you are saying that the mechanical relay system is not suitable, but that has been the system in place. I put it to you that if I am to choose between the electromechanical relay system and the embedded system to control an industrial process, I will gladly go for electromechanical relay system. When we are talking about the suitability, we will be considering the cost. We will be considering the durability. Maintenance, as you mentioned earlier, is also a factor to be considered. Now, talking about durability, one of the major attributes of PLC is the fact that it is rugged, can withstand an hazardous environment, can withstand an environment that has high temperature, high pressure, high conditions. It can withstand harsh conditions. Relatively to an embedded system, if you break an Arduino close to the boiler, I don't need to tell you what would be the outcome. If you bring an Arduino is a type of embedded system. Okay, if you bring it on the Raspberry Pi, so if you bring an Arduino close to let's say a system of like 100 degrees centigrade now, okay, that doesn't mean that you can't put your PLC to other condition. But I just say so the PLC can withstand harsh conditions better than the electrical. And even the electromechanical relay system can withstand harsh conditions better than the embedded system. But when the embedded system we have an enabler and electromechanical relay system is that it is smarter. Okay? You can program it. So majorly electromechanical relay system has to do with how you can wire the system to control your actuators for output. Then during the course of maintenance, over time, a lot of things are changed, especially in the settings where maintenance software is very, very poor. Or a norm where you make changes, you should always reference this change you do at a particular time. If it is not well documented, at the point you will not be able to trace the faults in an electromechanical and PLC system. And that might mean that you might have to probably rewire the whole system or do all sort of hard work. But in the case of a PLC or even an embedded system, all you might need to do is to reprogram or repurpose uh, your, your system. So that is now based on costs now. Electromechanical relay system can seem cheaper than a PLC, but when you run it over time, a lot of changes will be made. Change the relays, change some other components, which in today's time are already present in the PLC as a form of a source program. For example, there used to be timer relays. Have you ever wired star data before, or do all those motor control? You have wired star data before. Okay, Joshua, tell us how star data operates.
Basically, I'm just looking around the base and the timer relates software to the restriction of the way of control out.
So when you have a star data panel or star data control system, you have an interconnection of release even with timer to differentiate, okay, this is when you operate on star, this is when you operate on data. When you get to your motor control class, it will be not those things. Now you will have your normal relay system, you will also have a timer relay that will like be the one to tell the time the switching will take place. But it means if there's anything wrong with that system, you have not just some other components to change. You might be spending money on changing your timer relays and all. But if you are bringing a PLC into that settings, you can just use uh, the timer function that is already inside the PLC. Okay, so we have counters too, and you also have a lot of functions inside the PLC that normally you are supposed to have an hardware device that will be doing those functions. Okay. But with the PLC, all you have to do is to program all of those functions, use them, and if there is any changes that you used to do, you still have to do the program. So by the time I change timer today, I change another relay tomorrow, by the time I accumulate all those costs together, you will realize that at the long run, an electromechanical relay system is much more expensive than the PLC system. Okay. So these two guys beat this electromechanical relay system at that. Just that this guy cannot withstand harsh conditions. Okay. So now the simplicity of this guy over the PLC over embedded system is that it has a kind of programming language that is easily understandable by the technicians. Not everybody go through the 4 walls of schools to learn C++, to learn Python, and all. Be as it may, for those that want to spend a long time in the industrial and automation engineer, you might still it is advisable that you try and learn the high level languages as things are changing. But this PLC has a programming language called the ladder logic. So that ladder logic, it's mimic your typical electrical system. Okay? So in a typical electrical system, you can have something like this. Okay. So this, I also now. So this could be interpreted into this ladder diagram. Okay, so that ladder diagram is easily understood by an electrical person. Okay, this is how this signal is flowing. This is how this thing is operating. That's one of the simplicity that your PLC helps to helps for your system. Now, so that being said, again, a PLC, Programmable Logic Controller, is an industrial computer that is used mainly to automate industrial processes. Okay, so you can also use it in your own automation. You can use it in your office automation, any form of automated process that comes to your mind. You can use it. But another thing that might not allow you to use it is the cost. Okay, before we proceed, any question? Any question? Any addition, any subtraction? Alright. So now that we know about PLCs, we can now talk about the types of PLC. Either say types of classification. Any of the two shall. So what are the types of PLC? Or even the classifications of PLC? Upper PLC is a type of PLC. Let's do it this way. Let's do it this way. Let's talk about the classification of PLC. So how can we classify PLC? How can we classify PLC? Yeah, classification by size. By size. By power supply.
Construction. Then compact and modular construction. Construction.
Okay. Now, first by size. Small, medium, large. Okay. So now we just going to limit it to this thing here. Majorly because when you are talking about the classification of sizes, we that variation also starts from that point. And when I say variation, I mean OEM variation. The way Siemens will classify their PLC based on sizes is different from that of my. Okay. So because the dimension of the PLC or which are one of them is different. Okay. So in some classification you might see micro. Okay. And still see small, medium, large. Some might be limited to these three, while you can still see micro, small, medium, large, something like that. Okay. So and you just literally you have the small, you have the medium, and you have the large. Okay. So in the case of the Siemens now, you can say 400. Let's have 400 PLC. I don't know. Let that it's not yet.
300. I think this is training.
So
So training or convention.
Convention.
maybe you have sent that PLC for that 400, that is the PLC on that board. Okay, so you can say it's a large PLC. Okay, then the 300 PLC you can see it as medium PLC. There used to be an SM 200 PLC and a Yogo PLC. You see they are very small, right? So you can say they are small PLC. Okay. So and then coming to the 1200 and the 1500, you can see okay, the 1200 is medium, the 1500 is large. Are you with me? Now when you now go to algebraic now, you have the micro logic. You see the PLC is very small. There's another PLC they call micro PLC. Okay, maybe micro 800 or so. So it's always small PLC. You have the compact logics and you also have the controllers. You can classify them as medium or large application. The size also at times, the way they classify the size at times too can be based on the capacity, the kind of application they are used for. Okay, so that's also how they classify the size at times. Okay, so for this size and maybe the function at times can be confusing. For these two, they will never get it wrong. Okay, power supply, classification based on power supply, and classification based on architecture. So classification based on power supply is there are two classifications. We have some PLC uh, with SMPS. Okay, and you have without SMPS. Okay, you have with SM, you have PLC with SMPS, and you have the one without SMPS. Yes, switch mode power supply. So a typical PLC uses 24 volts. Okay, 24 volts DC. And then you can have a PLC that is directly powered by 220 volt AC or maybe 110 depending on your region. For Nigeria, it's 220 volt AC. Now, when you have a PLC that you can supply 220 volts directly, you say you have a PLC with SMPS, switch mode power supply. It means that there's an internal circuitry for that PLC that will help you convert the 220 volts into 24 volts. Okay? So, but the one without SMPS, it means that you will need an external power supply that will help you convert the 220 volts to 24 volt DC, and then you will now supply the 24 volt DC to the PLC. A PLC with SMPS with switch mode power supply is a PLC that you can directly connect 220 volts to. So there's an internal circuitry in the PLC that will help you convert the 220 volts into 24 volts. However, the one without, it simply means that it can only take in 24 volts DC. So for you to be able to power such PLC, you will need to get an external power supply that will help you convert 220 volts to 24 volt DC, and then you and not supply the 24 volt DC to PLC. Okay, so now an example, there are some SM1200. When we get into SM1200, we will talk more on that. There are some SM1200 that you will see that they are AC, DC, relay. There are some that see DC, DC, relay. This particular AC here, the first one, is telling you the kind of power, the kind of input power that the PLC requires. So this one is saying that this AC/DC relay is saying that you can supply 220 volts directly to that PLC. It means it has SMPS. But this one that is this DC relay is saying that you should supply 24 volt DC to the PLC, which means you need an external power supply that will help you convert your 220 to 24 volt DC so that the PLC can be powered. Okay, so when we are breaking down the components of explaining SMHI conflict, we'll talk about what the other things mean in this. Are we together? Okay. So now to the architecture. So how does it look? How is it built? There are two basic modes of the architecture. You have the compact and you have the modular. Compact and what? And modular. So for compact PLCs, you say compact PLCs are self-sufficient. They are what? Self-sufficient. Meaning if you have a compact PLC, at least minimally, you can go ahead with your automation. Because the compact PLC we have a CPU, it will have an input module, an output module embedded into one device. Okay, like the 1200 you have there, all SL 1200, they are compact PLC. Okay, there are some SL 300 that are compact PLC. Now, for the S7 1500, S7 1500, majority of them are modular, except for 1511C and 1512C. So we have just two of that model that are compact, meaning they have inputs and outputs module attached to them. Okay. In your front now, you have SM 1200, you have SM 300, and you have SM 1500. All of them that you have there are compact because the 1500 that we have here is 1511C. Okay, it's 1511C also. The 1500. You see? Are you with me? Yeah. So now to the other side, modular PLC. So when you say PLC modular, it means that all these components are separated. So the CPU is separate from the input modules, separate from the output modules, and any other modules that you can have in a typical PLC. So it means you having the CPU alone is not enough for you to carry out your automation task. Okay, so it means you are meant to buy your module separately. You buy the CPU module, you buy the input module, you buy the output module, and any other module that you need for your product. Okay, they are separate. Okay, so if you look at that 50, the 400 that we have in the training room, you realize that you can remove some part of it. Okay. So they are modular, you can remove from them, you can change them infinitely as well. Are we together? Okay. So for the compact PLC too, and it goes your modular PLC, the way they are designed, they can take on more responsibility than even your compact PLC. However, the compact PLC also gives room for expansion. So beyond what you have here, you can also buy some other expansion modules, some other IO modules to expand your system, depending on what your automation you are trying to do. Okay, so So at first, when you are starting a project, it is expected that you consider how large your system is. Okay. So before you even select the kind of CPU, not that you just say okay, 1200. Well, it's not as if you cannot use the compact PLC, there is room for expansion. But by the time you look at it, you might end up spending more and then not even managing your space. For example, your space, your typical control panel, you might not be managing your space very well. So now we also have distributed IOs. Bring that in. Typically, in the Siemens world, we hear things like ET200. Okay, so it's such that if you have a large automation process and then managing space is also of importance to you when you are setting up your control panel, those distributed IOs are always smaller than a typical PLC. So you can decide to design it such that you can have just one CPU that will be 1500, for example, and then that 1500 will now be connected to the distributed IOs. Okay, but majorly, where you use distributed IO system is going to have a distributed system. Okay, so later on in the classes, we are going to be talking about the distributed system. Okay, so I just need you to have that at the back of your mind. Okay, so any question? Let's look at brands of PLC. So, what are the brands of PLC now? You said?
PLC very functions.
Okay, we're not talking about the function. Extra. PLC by functions. Oh. Or by purpose.
Let me do.
Classification is done because of even though we have PLCs stand there, they are used to there are also some PLCs can stand as we can sometimes the general PLCs and there's also CC PLCs. So CC PLCs are the purpose they serve is that in case of it's an industrial setting, so there's a tendency of hazard or these are kind of PLCs that are designed to they are rugged and they are meant for intervention in terms of unsafe circumstances. You understand? And the way they are usually more expensive than the regular ones they get. And they can withstand harsher conditions compared to the general PLC. And also there are some other PLCs that I think they are for
Technology.
yeah, technology PLCs, yes. So they can interface with technology objects like motors, drives, and the like. So they usually have higher precision and higher processing speed compared to the regular PLC. So I don't know if I missed anything. So,
the technology is better than the normal.
depends on what you want. Depends on the purpose. So technology PLCs can interface easily with technology objects like thermal drives, motor controls, because they usually have higher processing speed. So they process faster. Even though general PLCs are fast, but those ones are kind of faster compared to general ones. So in terms of precision. And safety, that one is for intervention in terms of unsafe conditions.
So at the end of the day, there's none of these PLC that you can use for what you want to do. No, it's just about the ideal thing to do, the standard. Okay? So for a general PLC, you use it for your normal, all those your process control system and all. So when it comes to safety PLC, when you see something like SIS, safety management system, that's where you see safety PLC. SIS, safety management system. Okay? So at times the color too will let you know directly that this is so I think Schneider and Alexander, when you see like it's a safety PLC. For Siemens, I think it's yellow. Okay, so when you see yellow, it's just safety PLC. Okay, when we dig them into PLC, since we are doing Siemens now, we are going to show us some of the safety PLC. Okay, and for the technology PLC, there are PLCs that are for that have the ability to perform some special functions. Okay, these are these high-speed counting. Okay, so control of servo or even a stepper motor when high precision is needed, and also your PID functions. Okay, so you will have some PLCs that can do that. Beyond even the PLC, some modules too are also for some of those things. But at the same time, some modules are compatible for a specific type of PLC. Okay, so your application will determine what type of PLC that you are going to do. So it goes beyond, okay, this is the number of digital inputs we have, this is the number of digital outputs we have, this is the number of analog inputs that we have, this is the kind of analog output that we have. You also need to consider what function are these things performing, which particular PLC will be better for you. So typically, your safety PLC is not there to do your control, to be doing your normal control. What its own is just to ensure safety of your system. Okay, so if you are going to have a safety PLC in place, you are supposed to also have a PLC that is taking care of your normal control. So that's why you will have that.
I think the safety PLC supposed to be normal. The general, if you work for general PLC, you're still going to have the general safety feature.
This is it. Your PLC, your general PLC, what we call general PLC. There's a way you will program it that will do even your safety too. Now, safety PLC already is having that capacity. You can also program it to control what you want to control. Are you getting it? But we are talking about the standard. Okay, so let your normal general PLC be for your process control system. Let your safety PLC be for your safety system. In a typical oil and gas setting, when you go to their system, you will see PCS, you will see SIS. When you open the two panels together, based on the arrangement that you are seeing on that panel, you will feel these are basically the same thing. Okay, but the color is the what? Is the different. Okay, so you just say that okay, the SIS is having the same setup, maybe F580 for the Schneider PLC. You see two F580 that are red, and when you open your PCS, you see two F582. Maybe it is black or white. Either of those colors. So you see that. So what we do? So the only thing there is that your PCS is the one responsible for the control of your system. CSI, the one that is at least to ensure the safety of the system. Okay. Are we together? The same way I use cutlass to dig ground, that does not mean that I'm using the right tool. I hope you get the point now. So back to the brands. Okay. What are the brands of PLC? Mixable. You say what?
Supercon.
Okay, you are representing. That's nice. Okay.
Siemens.
Siemens. I don't know Penco. I am brand Schneider. Mechanic. Schneider. When you Siemens is actually the most popular brand of PLCs throughout the world. Okay, but you see Siemens used more in the manufacturing industry, the food and drug. Okay. But when it comes to oil and gas, you tend to see more of adding. Okay. ADB is different from we are going to be limiting ourselves to Siemens for now. Then later on, we go and meet this brother all the way from the United States of America, Germany, USA. And then we're also going to visit our people in Japan. We have two major artists that I know of, series of Siemens PLC. We have the S5 series. They are very so responsible. And we have the S7 series. Although we still have S5 series. Okay. The very old man. Now the silent guy. Okay, we still have them in some of the industries. So for S7, we have from S7 200, we have the 300, 400, 1200, and 1500. Okay? These two being the latest period. The 1200 and 1500 being the latest. Okay? The 1200 is an old PLC that is obsolete already. That's been buried. It used to be programmed with microwave. So, and then 300 and 400. We have the step 7 software for them. You said? They will be buried. And because of the use case of 400, because of the use case of 400, they cannot very what's the use case of 400? Rocket on the rugged. We had this year. We were late this year. The Siemens was the use of 400. But that does not mean they are prohibited 400. Everybody can you can still use it. Besides, people are still using S5. They are talking about what we can be using to program it. When it is discontinued, they are when it's continuing, they are no longer producing. And then Siemens will not support you for anything. You can still be using it.
Your iPhone, what you use? Never discontinue the one you use.
Waiting me I put talk. I put 5 talk. Waiting me 5 talk.
Never just continue. I just say your huh? Yeah, exactly.
People say it's fine.
So that's just it. It doesn't mean that it will not work again.
That's a simple way of giving the explanation.
So if you
My
want
Samsung,
anything
you
that
have
is
to
going to
continue.
support you on, it has to be 1200. So these guys are being programmed by step 7 software, version 5
Fine.
upward or higher. Okay, and then some of them, not all of them, some of them can also be programmed by TIA portal, which is also step 7 software version. I think it starts from version 10. Okay, so don't make that mistake. What you call your semantic manager, even the TIA portal, they are all step 7 software. Okay, so it's not the version now. Some version for the version 5, the whole software is managed by semantic manager. But for version 10, 11, 12, up to 20, they are being managed by TIA portal. Okay, so but at the same time, they are still step 7 software. So and TIA portal and even semantic manager, they are just managing software under the step 7 software. You have your ladder editor software, you have your hardware configuration software, you have your network communication software, they managed by those. Okay? So, and then the 1200 to 1500 is step 7 software. Yeah, okay. So, um, basically, we are going to be looking at the 300, 1200, and 1500 in our class. So, and things have changed, anyways. Since we can still use TI Portal to program the 300, we are not going to be taking you on semantic manager or any step 7, 5, 5. So we are going straight into TI. So if for any reason you come across a situation where you can only use semantic manager, step 7, 5.0 or so, then maybe we can look into how we can solve that problem. So let's move with the flow. That's nice. It's okay. So we are going to be using TIA portal to program all the signal systems that we have. And the beauty of TIA portal is, unlike the Station version 5, where you have the separate software for PLC, separate software for HMI, separate software for VFD, with your TIA portal, you can be able to configure your PLC, configure your HMI, configure your VFD on the TIA. So you just need by default the TIA portal that you saw will come with the software for the PLC and HMI. It will not come with the VFD. So if you need to do VFD, you might need to install the one that will enable you work on VFD. And there are some other packages that may not come with it as well. So maybe based on the kind of software that you will install. So because WCC, for example, is for HMI and SCADA system. Sorry, Siemens. So we have, I think we have about 3 or 4 types of WCC. Now we call their name. I know I'm listening to professionalized for skill. The other one is for HMI system. So you might have the one that does not have the OCC professional installed. So you just need to install it so that you can be able to use it. So and it's part of licensing to some of these things. So for every system, you have to buy the license, both the software and the hardware. So when we get to HMI, we talk about licenses that has to do with it. You have to check that has to do with the panel image and some other things. So but for now, let's just focus on the PLC. Okay? Yes. All right. So now, you have a thinking on this. There is a way the idea of the thinking system is. So you have, let's say we have a typical thinking system. You have the first node. Okay? Always reserved for the PLC. Power supply. You can choose to use or not to use this one. Okay? So you have the sinking node that follows this. And then from theory, there is IN, interface mode. And then from 4 to 11, you can have either of your signal modules, your communication processors, or function modules. Okay, from that 4 to 11. Okay, so signal modules, we are talking about your digital input, your digital output, your analog input, your analog output. For communication processor, you will be having a module that can help you have communication with other devices. So this communication processor might be having Ethernet, in this case Profinet. You can have the one that has Profibus and any other form of communication that you need. So for the function module, you can have a function module that is majorly for high-speed counting. The one that is for PID or any other kind of function, social function that you want to perform. So both in your hardware and software, okay, this is the picture you should have in mind. Okay, so when you are, let's say you are developing your panel, you are trying to wire your panel, you should have these particular settings in mind for S17 PLC first. Like I said, you may or may not know, you may do without this particular one. Okay, so then the CPU will be in the second one, in the second slot. The interface module will be in the third slot. Only the CPU, only the PSU can be in this slot. Only the CPU can be in this slot. Only the IM can be in this slot. On the software, we are doing your hardware configuration in the software. But let's say in the physical sense, in your hardware, your panel, this guy might be left out if it is not needed. If it is not needed, this guy might be left out. And then the next thing that will follow it can be your signal modules physically. For your software, you will have to omit this number 3. We get it. Okay. So like this. So for the so you can omit this guy physically, but your software you can never put any other module. In fact, it will not allow you to put any other module. There is no single one that you can cannot put any other module in this place. Then the signal will be PID, or you can put it CPU, you can put it in any of those any of those levels. And I think you can be able to let's say this is like 0, okay? You can be able to configure another rack on the same CPU. So this, let's say this is rack 1, okay? So power supply will be there. There will be CPU. So there will be an interface module, and then you can put your signal modules again from 4 to 11. Okay? So the only reason, this is where we are going to answer your question. The only reason why this guy will be used is because we want to do what we call multi-tier configuration. Multi-tier configuration. Okay. Multi-tier configuration. And why are we doing multi-tier configuration? Basically, you have a system. Your system is robust, it's large, such that you exhausted your 4 to 11 slots that are for your signal module, CPU, and you need to actually control some other things. So you need to bring in another rack into the settings. So, and you are still going to be using the same CPU. So in order to link up this rack and this rack, it's why you will need an interface module. Okay. So it's just to serve as a form of communication between the two racks. Also, your interface module also serves as a means of communication between your CPU and distributed I/O system. So let's say you have 8200, okay, which is also controlling some other things for you. You will need an interface module to communicate with it. Do you get example? So for 300 systems. So, but when it comes to 1200 and 1500, you don't have multi-type configuration. So what is encouraged in 1200 and 1500 is distributed system, distributed I/O. So you need something like this. So for example, the typical 1500 system can have up to 32 modules. If you now need beyond that 32 module, what you will be advised is to use a distributed I/O. So bring an 8200 SP or so to the picture, and then use it for one strong I/O. It's very great.